Welcome back, CE. We're going to start with large and small numbers and significant figures. Okay, so to work with very large numbers and very small numbers, we use a thing called scientific notation. Let's look at a large number first. Okay, here's a very large number. Now, rather than have to write that out and trying to keep track of how many zeros that we got, we're going to write it in scientific notation. In order to do that, we put one number in front of the decimal. We take that number, which would be 3.65, and times it by 10 to some power. To get that power, what we do is we say the decimal used to be here, back here. And I need to move that decimal so it's right here, up here. So, we're going to count as we move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 20. So I have 29 places that I need to move. So I put that power of 10 to the 29th. That tells me I've got 29 places that I need to add after that. Okay, so here's another number we're going to do the same thing with. Not as many zeros, so we'll make it a little bit easier. Again, we go through and we say, okay, we only want one number in front of the decimal. So I'm going to end up with 4.75 times 10 to some power. Again, to get that some power, I start here, and I want to get to right here, where the decimal's right there. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put 10 to the power of 10. Okay, so that works with big numbers, but what about small numbers? We're going to be working with really small numbers, so let's look at. Okay, so here's our really small number. We're going to do the same thing that we did before. We're going to put one decimal in front of the first number. Well, the first number, the decimal is going to need to go right here. So we're going to get the number 7.8 times 10 to some power. So we're going to do the same thing. We're going to move that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places. But this time, because it's a very small number, we write negative 14. So it becomes a negative. Okay, let's take one more number here. This number is also very small. We're going to move the decimal so there's one number in front of it, so it'll be between the 6 and the 5. So we will get over here 6.45 times 10 to some power. Let's count and see how many we've got for the power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to need a negative 12. I hope this makes good sense for you and that you can go back and forth between the two. Okay, here's some examples. I'd like you to pause the video and see if you can get the right answers. I'll put them over on the right here in just a second. Okay, here's the answers. How did you do? Well, let's go on to another. If you're having problems, there's some sites that you can get from the blog that practice scientific notation, so please do those. Okay, so to do multiplying or dividing with scientific notation, you just have to remember the rules of exponents, or make sure that you put it into your calculator correctly. The rules of exponent basically says if I multiply it, all I have to do is add them together. So I would take and I would multiply this by this and just add the exponents together. So the exponents on the far side should be around times 10 to the 20. Now I know that 3 times 6 is 18, so I'll probably have to move the decimal one more place, so it'll probably be 21. But this is a good way to just double check. I know a lot of kids do things on their calculators and say, but the calculator said so, so it must be right. If you know this little trick of adding the exponents, and this is about where it should be, right here, this 20, if that's about where it should be, it can be off by 1 or 2, but I should be right close to that. Then I don't have to just take the calculator's word for it. Because if I don't put this expression right here in correctly, I'm not going to get the right answer over here. So as I put this into my calculator, you are going to put in 3.45 times 10 to the 34. And you're going to have to use your caret or exponent. Please do not use the 10 to the x button. It will throw you off. That is a big no-no. Okay, so just put it in with the caret button, and the caret button is that, or the exponent button. Then you're going to times it by parentheses and then times it through. Okay, we should end up with something, like I said, 3 times 6 is about 18, so I know I'm going to have to move this, so we're probably going to be up, instead of 20, it should be about 21. So put it through your calculator and see what you get. The correct answer is now listed on your screen. How did you do? If you got the right answer, wonderful. If not, we probably need to do some more. Again, there's a bunch of sites that you can go and practice this. There are several examples in your book that you can use to practice. Just remember the little trick that I taught you about this. When you're multiplying, just add them together and it will get you close to where you're supposed to be. If you put in your calculator wrong, then you know that you're wrong, because it should be within 1 or 2. Okay, let's look at dividing. On dividing, what you want to do is you want to take these exponents and you want to subtract them. So you take 30 minus 34 minus a 54, and you should end up with about a negative 88 for an exponent. Now if I don't end up with about a negative 88, then I know I did something right. Now this is where it becomes very, very important to use parentheses. So I'll put the first number in, I'll hit the divide sign on my calculator, and then I parentheses, put the second number in, close parentheses. Don't forget to use the caret to get your exponents in. So take a second, throw it in your calculator, and see if you get the correct answer. Okay, so you should have got from your calculator 1.64 times 10 to the negative 88, and that was right where we said it should be, as negative 88, so I put it through my calculator correctly. Now remember, on multiplying you add the exponents, and that should get you close to what your calculator should say. If not, you're putting it in your calculator wrong. On dividing, you subtract the exponents, the top one minus the bottom one, and that should get you close to your exponent that you should end up with, whoops, sorry, move that around, right here, which is what we ended up with. Okay, so if you need more practice, again, there's more in your book, and there's several sites online that do a wonderful job. Okay, so the next thing that we need to know besides working with large and small numbers is what kind of significant figures that I need to keep. Significant figures tell me how well I measured something, and they keep it so that I can say that I'm this exact. Okay, so zeros that tell how big or how small a number is are not significant. Let's look at a couple numbers. Okay, 3,000 or 30,000. Those zeros that trail there are not significant. They just tell me how big or how small, and if I put it into scientific notation, those zeros would go away. Same thing with this very small number. If I put it into scientific notations, those zeros would go away. So these are not significant. Okay, rule number 2. Zeros between two non-zero digits are significant. So let's look at example. Okay, 2014. The 0 there is smashed between the 2 and the 1, so it is significant. Here we've got on the next one a couple zeros. These zeros here are significant. That one is not, because it is just a placeholder. It just tells me how small it is. So if it's between two digits, like the 1 and the 2 on both of these, they are significant. Okay, and the last one, zeros that follow a non-zero digit and are after a decimal are significant. And I guess I should have put at the top the significant figure rules. Any number 1 through 9 is significant when you see it. So let's look at an example of this one. Okay, so as you look at this one, this 0 is after a decimal, but it's after a number. So this tells me how well I measured it. I like to look at that. How well did I measure? If it tells me how well I measured it, then it is significant. So I measured to the 10th place, and that is significant. The 0 before the decimal is significant because it's after a number, and there's a 0 after the decimal. So I have made that clear. Now sometimes you will see something like this with a line above it. that line is like saying I measured to that point. It's not a repeat sign, it's just I measured to that point. Sometimes you'll also see a decimal after it. That just means I measured to the ones place. So be aware of those two things. Okay, so we're going to do some problems with adding and subtracting with significant figures. Let's talk about the rule. There's one rule for adding and subtracting and one rule for multiplying and dividing. Basically, on adding and subtracting, you can only report to the place that they both have in common. So I'm going to divide this in half here, and on this side we're going to do adding, and on this side we'll do subtracting. So we're going to take some problems. Let's take 3.007 plus 13.89. And I want to get the answer to the right correct significant figures. I like to take it and say, okay, I need to rearrange that like old-fashioned, like I'm in elementary school and I need to add. Remember how they taught you how to add, where you stack them on top of each other, line up the zeros or the decimals, and then you'd add it this way? Well, if I put that through my calculator, I know I'm going to get 16.897, right? Well, I can't report all that. The last place that they both have in common is the hundredths place. So what I need to do is I need to look just past the hundredths place to this place, and if it is greater than 5, I'm going to round. If it's not, I'm just going to drop it off. Well, here it is greater than 5, so I would report for my final answer 16.90 because it will round up, and that will be my answer. You do the same thing with subtracting. Say that I had 2014 minus 178.32. Okay, so I'm going to line these up again with a decimal so that we can find out how many we can report. We can run this through our calculators, no big deal, but we do need to know how many places that we can report to. So if I take and subtract these two, and I've lined them up, they actually go through right here. So off the calculator, when I put it, this is the answer that I get, but I know that I can only report to the ones place. So I look at the tens, and it is bigger, so I'm going to round it up, and I would report 1836 as my answer. Okay, we have different rules for multiplying and dividing. So adding and subtracting, you have to line it up and take the the last common they have in both. But multiplying and dividing becomes very simple. We can take two numbers, say 2.37 times 17.13, and I can quickly tell you how many answer I can have in the answer, because I look at how many is here, which is 3 significant figures, how many is here, which is 4, and I can only have the smallest amount in my answer. So quickly put those in your calculator and let's see what the calculator answer. So this is what I got for the calculator answer. I said that I could only have 3, so I start here and count 1, 2, 3. Again, I look at the next one. If it's bigger than 5, I'm going to go up, so I would report 40.6. Done. Same kind of thing happens with divide. You can take and say 36.25 divided by 4.5 equals, that's a 5. Again, look at how many significant figures. This one has 4, this one has 2, so my answer can only have 2. Plug it through your calculator. This is a calculator answer that I got. I can only have 2 in my answer. Now that becomes a problem, right? Because if I just put 2, that's 16. Well, I've got to hold the place to tell how big it is, so I've got to put a 0. Remember, that 0 is not significant, so I'm still doing what I need to, or I could put in scientific notation, which would be 1.6 times 10 to the second. That shows me I have 2, so either of these answers is correct. Now both your book and the site that I've linked with the blog have tons more examples on how to multiply and divide and add and subtract and do significant figures and do scientific notation. So if you don't get it from what I've put here on the blog, please go to those places. We'll also be practicing in class. We'll see you next time.